Hello, welcome to next material of the course. It is special video because of the sponsorship and the great footage from Vidu and Vidizi. We made the decision should to go to the location by plane, but we need transit more than one airport. For your information from TripAdvisor, commercial air carriers serve Las Vegas, Phoenix and Flagstaff, while a number of air tour companies serve Grand Canyon Airport in Tucson, just south of the park's south rim south entrance, mainly from Las Vegas and V. However, none currently offer transportation-only options. There is no airport at the North Rim. We continued our trip by car. Grand Canyon National Park, South Rim, is located 60 miles north of Interstate 40 at Williams via Arizona Highway 64, and 80 miles northwest of Flagstaff via US Highway 180, not recommended for winter travel, or only a few miles more from Flagstaff. By taking I-40 west to the junction with Arizona Highway 64 north. A third route from Flagstaff takes you north on US Highway 89, past Sunset Crater and Wapatki National Monuments, then west on Arizona Highway 64 to the east entrance of the park's south rim at Desert View. GCNP is 230 miles, 4 hours, from Phoenix and 280 miles, 5.5 hours, from Las Vegas. Only 10 miles from rim to rim as the crow flies. The North Rim is 215 miles, about 4.5 hours, from the South Rim by car. The North Rim is 44 miles south of Jacob Lake, Arizona, via Highway 67. Visitor services and facilities inside the national park on the North Rim are only open from mid-May through mid-October. Highway 67 is closed just south of Jacob Lake from the first snow in October/November until the middle of May. It does not reopen early if the road is passable before this time. There is no public transportation to the North Rim. All private vehicles entering the Grand Canyon must pay a $30 entrance fee, which is good for 7 days. Individuals on foot or on a bike must pay a $15 entrance fee, also good for 7 days. Exceptions: those holding an annual pass, $80, valid for 1 year, senior pass, $80, valid for life, available to U.S. citizens 62 and older, a volunteer pass, free, available only to individuals who have amassed 250 hours of volunteer service with one of 5 federal recreational agencies, or an access pass, free, available only to citizens or permanent residents of the United States who are medically determined to be blind or permanently disabled. Note, an access pass can only be obtained in person by showing proof of medically determined permanent disability or eligibility for receiving benefits under federal law. History. The park was founded as Grand Canyon National Monument in 1908 by President Theodore Roosevelt and became a national park in 1919. Today the park contains over 1.2 million acres, 490,000 ha, slightly less than the entire state of Delaware, and in 2004 received more than 4.3 million visitors. The Grand Canyon fills me with awe. It is beyond comparison, beyond description, absolutely unparalleled throughout the wide world. Theodore Roosevelt. The canyon is an overwhelming experience, and nothing can prepare a visitor for the sight. The Grand Canyon is a massive canyon carved over several million years by the Colorado River. Grand Canyon National Park boasts an elevation change of nearly 7,000 feet, 2,130 meters, from Point Imperial, at nearly 9,000 feet or 2,740 meters, to the banks of Lake Mead, at just over 2,000 feet or 610 meters. The canyon itself is, from rim to river, over a mile, 1,610 meters, deep. In spots, the rock layers exposed in the canyon display over 2 billion years of geologic history. Introduction. The Grand Canyon of the Colorado River is one of nature's most awesome works. It is to watch on video and see it for yourself. One of the most impressive aspects of the Grand Canyon is its enormous size. The average width is about 10 miles, depth 1 mile and length 277 miles. In addition to its enormous spatial dimensions, the Grand Canyon has one of the most extensive records of geologic history, representing over 2 billion years of sedimentation, mountain building and erosion. We will visit the north rim of the Grand Canyon. Going over the edge, the view from the south rim is spectacular for the sweeping panoramas, but to really experience the canyon you should take the time to do at least a short hike down below the rim and see it on a different scale. Stratigraphy. Rocks of the Grand Canyon range in age from Proterozoic, Precambrian, to Permian. However, the geologic record is incomplete with Ordovician, Silurian, Mesozoic, and Cenozoic rocks missing. Breaks in the geologic record are termed unconformities, and the time periods that are not represented by rock units are termed hiatuses. There are 14 major unconformities in the stratigraphic section, exposed in the Grand Canyon. There are 3 different types of unconformities, all of which can be observed at the Grand Canyon. A nonconformity is where sedimentary rocks are deposited directly on igneous and metamorphic basement. Nonconformities occur where the Precambrian Vishnu schist is in contact with the Precambrian Grand Canyon supergroup and Cambrian Tapetes sandstone. When the rocks below the unconformity have been tilted due to mountain building, it is termed an angular unconformity. The contact between the Precambrian Grand Canyon supergroup and the Tapetes sandstone is an example of an angular unconformity. Disconformities represent periods of non-opposition, where the rocks above are parallel to the rocks below the unconformity. Disconformities form in response to the lowering of sea level. The unconformities within the Paleozoic section, such as the one between the Mississippian Ridwall limestone and the Pennsylvanian Supai group, are disconformities. Paleosols, ancient soil horizons, often occur at disconformities. The lower Paleozoic of the Grand Canyon is similar to rocks throughout the North American. During this time, the North American craton and its continental margins were relatively stable. The craton experienced a series of major transgressions and regressions where sea level rose and flooded the continent, followed by a lowering of sea level. L. Sloss, 1963, observed this similarity in cratonic rocks of North America, and divided the sedimentary record into 6 cratonic sequences which he named after the Plains Indians. The Grand Canyon tells the story of North America. Knowing how and where rocks are formed allows us to read the story written in the rocks. A mile thickness of rocks of the Great Plains are exposed by uplift and erosion by the Colorado River. Separate the larger puzzle into a series of smaller puzzles, that is, each group of rocks, metamorphic rocks, oldest, intrusive igneous rocks, sedimentary rocks lying on an irregular metamorphic surface, sedimentary layering, erosion of the canyon. Each group of rocks is separated by a gap in the geologic record, formations and contacts. Metamorphic rocks, metamorphism. Granite intrusion of silicic magma. Eroded surface, uplift and erosion. Sedimentary rocks, shallow inland seas. Erosion of the canyon, recent uplift. Metamorphic and igneous rocks, metamorphism of sedimentary rocks. Igneous intrusion during later stages of metamorphism, during mountain building. Uplift and erosion, during and after mountain building, sedimentary rocks. Deposition of sediments on eroded metamorphic and igneous rocks. Uplift and erosion exposing sedimentary layers and eventually expose igneous and metamorphic rocks again. Erosion and exposure, uplift and erosion exposing sedimentary layers and eventually igneous and metamorphic rocks again. Geologic history. The oldest rocks exposed in the Grand Canyon are the Proterozoic Vishnu schist. Approximately 2 billion years ago, 25,000 feet of sediments and volcanic material were deposited on the seafloor. These sediments were metamorphosed during a mountain building episode 1.7 billion years ago. The rocks were folded, uplifted, and intruded by granites, xeroster granite, resulting in the formation of a mountain range that is believed to have been 5 to 6 miles high. Between 1.7 and 1.2 billion years ago, these mountains were eroded till only the roots remained. 1200 to 800 million years ago, a sea covered the area and sediments of the Grand Canyon supergroup were deposited. Mountain building, 800 million years ago, characterized by normal faulting, resulted in a series of Horston grabens. Subsequent erosion removed most of the Grand Canyon supergroup, except where it was down-dropped in one of the fault blocks. Approximately 550 million years ago, global sea level began to rise, and the Sauk sequence was deposited. As this sea transgressed over the Grand Canyon area, the following units, which represent a transition from nearshore to offshore environments, were deposited: Tapiz sandstone, a beach to nearshore deposit; the Bright Angel shale representing a muddy sea floor; and the Muav limestone, an offshore deposit. A lowering of sea level during the Ordovician resulted in erosion and formation of a disconformity. During the late Devonian, the Temple Butte limestone was deposited in a fresh to brackish water environment. Deposition of the Ridwall limestone, a marine unit, during the Mississippian marks a rise in sea level. A drop in sea level at the end of the Mississippian resulted in subaerial exposure of the Ridwall limestone and the development of an ancient karst landscape. The Pennsylvanian through Permian Supai group was deposited in a delta to nearshore beach environment. The Coconino sandstone is an Aeolian deposit, and the Toraoip formation and Kaibab limestone are marine units. A thick sequence of Mesozoic rocks was deposited, and subsequently eroded from the Grand Canyon area 65 million years ago. The Laramide orogeny produced the Kaibab monocline. Normal faulting and uplift began in the Miocene, 10 years, and continued through the Pliocene. During the late Cenozoic, volcanic eruptions produced basaltic lavas that flowed into the Grand Canyon. I will explain one by one. Let's see the simple animation. Regional uplift, tilting, or folding, erosion. Regional uplift, tilting, or folding causes erosion. Erosion surface indicates gap in geologic record. Regional uplift, tilting, or folding, erosion. Erosion surface, gap in geologic record. Continuous sedimentation. Regional uplift, tilting, or folding, erosion. Erosion surface, gap in geologic record. Continuous sedimentation. Sedimentation ceases. Erosion of horizontal beds. Erosion of horizontal beds. Erosion of horizontal beds. Loss of geologic record, that is, ARCOs. Formation of a horizontal erosion surface. Renewed sedimentation. Deciphering relative ages. Principles give sequences of geologic events. Unconformities indicate gaps in the geologic record. Cratonic picture shows each cratonic sequence is a large-scale lithostratigraphic unit, bounded by unconformities, that represent a major transgressive followed by a regression. The sequence boundaries are not restricted to North America, and can correlated with sequences on other continents, suggesting they represent eustatic or global sea level fluctuations. Stratigraphic units of the Sauk, Tippecanoe, Kaskaskia and Absaroka sequences can be observed at the Grand Canyon. Uplift and erosion. As the land is lifted up by tectonic forces, a stream will attempt to maintain its base level by cutting down into the rocks due to accelerated erosion. Structure. The Grand Canyon section is structurally the highest part of the Colorado Plateau. Structural relief is a measure of the elevation difference of corresponding stratigraphic units. At Bright Angel Point, the Kaibab limestone is at an elevation of 8,000 feet above sea level, whereas, at Bryce Canyon it occurs in the subsurface 0 to 1,000 feet above sea level. Because of its high structural relief, most of the younger Mesozoic units have been removed by erosion from the Grand Canyon section. The eastern Grand Canyon is centered on the Kaibab upwarp, a broad flexure or open fold that is bounded by the East Kaibab and West Kaibab monoclines. The monoclines trend north-south, and occur above Precambrian basement faults that were reactivated during the Laramide orogeny. Numerous normal faults dissect the Grand Canyon region, see figure. These faults formed in response to extensional tectonics associated with formation of the basin and range. The Bright Angel Fault is a prominent fault that controls the location of Bright Angel Canyon. Carving of the Grand Canyon. How old is the Grand Canyon, and how quickly was the Grand Canyon cut? How did the river cut across the many belts of high ground along its course? These are some of the questions that need to be addressed when interpreting the history of the Grand Canyon. One would think that a canyon of its size would take an extremely long time to form, which is precisely what the 19th century geologists believed. According to their models, the Colorado River established its course at the beginning of the Tertiary period, Paleocene, or Eocene, and as the plateau was uplifted, the river maintained its course by increasing its rate of erosion. It later became apparent that the history of the Grand Canyon was more complex, controlled by tectonic events, climate change, and a complex system of stream capture, episodic entrenchment, and aggradation. Elston and Young, 1989. Three main lines of evidence help us to constrain the age of the Grand Canyon. Lakita, 1989. First, the Miocene, 5 to 6 Mears, Muddy Creek Formation, which outcrops at the mouth of the Grand Canyon, records a period of interior drainage, and is evidence that a through-flowing drainage system across the basin and range province did not exist at this time. Second, the Beus Formation, late Miocene, of western Arizona is a brackish water estuarine deposit that contains fossils eroded from the Mancos Shale of the Colorado Plateau. This evidence indicates that the lower Colorado River was established by this time. Finally, volcanics in the western Grand Canyon are evidence that the canyon was as deep as it is today about 1.2 million years ago. These data suggest that the Grand Canyon is young, and downcutting of the canyon was rapid. One model for the origin of the Grand Canyon is illustrated in Figure 7. During the Miocene, the Kaibab uplift separated the upper Colorado from the lower Colorado, or Hualapai drainage system, which flowed into the Gulf of California. Headward erosion of Hualapai tributaries eventually allowed them to break through the Kaibab uplift and capture the ancestral upper Colorado River. This process, known as stream piracy, caused the upper Colorado River to be diverted to the Hualapai Channel. The rate of downcutting was suddenly increased due to the lowering of the base level and increased discharge as the two rivers joined, thus forming the Grand Canyon. Recent studies of the volcanic deposits of the western Grand Canyon have led to new understandings on the rates of canyon cutting. Numerous volcanic lava flows cascaded over the outer rim of the Grand Canyon in Torauip and Whitmore Wash, forming frozen lava falls. These lava flows formed a series of great barriers or lava dams across the Colorado River. Hamblin, 1989, has identified 12 major lava dams that formed during the past 1.2 million years. Relative age dating and calculation of erosion rates indicate that it took approximately 20,000 years for each dam to form and subsequently be destroyed. Following formation of each dam, the Colorado River rapidly eroded through the dam down to its original level but no further. This suggests that the Colorado River is in a state of equilibrium, and when that equilibrium is disturbed, such as by the formation of a lava dam, erosion to arrive at the equilibrium profile takes place almost instantaneously in a geologic time frame. There are still a number of questions concerning the origin of the Colorado River system that need to be resolved, such as the direction that the upper Colorado River flowed prior to stream capture, and inconsistencies in the age of different sections of the Colorado River. The important notes for all: the south rim of the park is open all year. Road improvement work is taking place in and around Grand Canyon Village. Please follow detour signs, flaggers, and temporary stoplights, and slow down while driving through work zones. The north rim of the park is closed for the winter. All north rim roads are closed. Hikers and cross-country skiers will be able to enter the north rim through the winter months with valid backcountry permits. Most visitors seem to be slowly driving the south rim and stopping at all of the same viewpoints, taking some photos, but doing little else. With a park so vast, it seemed like it would take a serious investment of time and effort to really experience what it had to offer and get away from the crowds. But even a short trip to the Grand Canyon can be rewarding if you know how to make the most of your time.